That's one way to make sure that your solution is it. But I'm pretty sure your solution is correct. So does anyone have a DP solution? Any idea of how the DP solution progress? So what do we want? We want to make S1 to Sn and T1 to Tm same, right? So the kind of thought process is something like this. Suppose I have the optimal solution. The optimal solution is a series of operations, right? So we are saying, so first notice that the operations can be rearranged. The order of the operations doesn't matter. I can insert at any point, delete at any point, and I can interchange these things. So I'm saying we rearrange the operations such that they kind of happen from left to right in a way. So it's a very vague notation. I'm not. This can be made formal, but I'm not going to make it formal. So like, if I'm going to add something here, I'll add something to the left. If I'm adding something here and I'm adding something here, I'll do this before I do this. If I'm deleting here and deleting here, I'll do this before deleting this. And arranging within them also can be done. But kind of get the idea of what's happening, right? So what will happen is, as time passes, this some prefix of this will be equal to some prefix of this, and then this suffix should be made equal to this suffix. That's kind of the idea we're getting to. Right? So very hand-heavy, but you understand kind of what we're trying to do. Take any optimal solution. I'm saying we can rearrange it so that all the operations take from left to right in a way. So it's in an ordered fashion. So that leads us to this subproblem, which is basically saying, take a prefix of S, take a prefix of T. What is the least number of operations to get these two equal? Suppose I can find this. How many such subproblems are there? There are S into, let's say, size of S is, it's n. So that's n into m such subproblems, right? Like, there are n prefixes of S, there are m prefixes of T. So there are n into m prefix pairs. So we're looking at dp ij is min cost to make S1, S2 to Si equal to T1, T2 to Tj. I want to make the I prefix and the j prefix equal by doing some operations. What is the minimum number of operations to make? What is the final answer? The final answer is dp nm. Right? I want to make the entire S string equal to the entire n T string. So how do you compute dpij? So again, going by the intuition which we had, in dpij, the last operation will try to make the last characters equal in some sense. So we focus on that. And if we guess what operation, if we will go over all possible operations which will make the last characters equal, and then it will be a subproblem, because once the last operation is taken care of, the previous operations will make some slightly smaller prefix and some slightly smaller prefix equal, which we get from a previous dp value. This is kind of the approach we'll be taking. Let's see exactly what happens. So to compute dpij, just write down the two prefixes. Now there are a couple of, I'll probably make a mistake somewhere in this value, so just be careful. Okay, so let's take the first case where Si equals Tj. That is, the last two characters are equal. If the last two characters are equal, does it ever make sense to change them or delete them or add something to their right? No, right? I have two equal elements which are at the end. So I might as well keep them equal and just focus on the prefixes. So in this case, again, dpij is just dp I minus 1, j minus 1. I'm not proving it rigorously, but you kind of understand why this is. I have two equal elements. Why bother do anything? Just forget them. Keep them aside. Whatever I want to do, I'll do it with the previous case. The length might be different, everything might be different, but all the length changings I can do in the prefix of the prefixes. I won't touch those waves. Okay. So this is an easy case. So non-trivial case is when SI not equals TJ. So SI is not equal to TJ. But finally I want the last two characters of, so let this be S and let's call this prefix S and prefix T, and let this be transformed to prefix S prime and prefix T prime, where prefix S prime equal to prefix T prime. So in prefix S prime and prefix T prime, the last two characters are equal. So what all could have been the last operation which we did? We could have changed SI into TJ using the third operation. We could have changed TJ into SI, but that is kind of same, right? It's just applying. Oh, that's not the same. Yeah, that's kind of the same. Okay, let's just think of them as separate things. I could have changed SI into TJ, or I could have changed TJ into SI, or I could have added TJ at the end, or I could have added SI at the end here, or I could have deleted SI and by chance maybe SI minus 1 was equal to TJ. I don't know. But for now I just delete SI and I let the previous things take care of these guys, because that TP value I already know. Similarly, I could have deleted TJ and by chance maybe TJ minus 1 or maybe TJ minus 2 was equal to SI. So I delete this and delete this, but for now I don't look at it. For now I just look at the first, actually chronologically the last step. I just delete TJ or I just delete SI. So let me try to put this in a more structured argument. I know that SI and TJ are not equal. So I need to do something and I can't keep both of them just intact like this. So what are the ways to change the last character of S and T?